everyone, and welcome to AWS Julie. For today's video, we're continuing with our new series on needed fundamentals to ensure you pass your AWS certification exams. Please remember to give me a like, subscribe, and remember to reach out with any questions or feedback. Let's dive into high availability, fault tolerance, and disaster recovery. In our last lesson, we did a high-level overview of the AWS Well-Architected Framework, and I told you we'll be taking a deeper dive into the pillars of the AWS Well-Architected Framework, starting with this lesson. So what pillar covers high availability, fault tolerance, and disaster recovery? It is the reliability pillar. Let's start off with high availability. We've already mentioned high availability several times, so what is it? High availability is a way to design your systems to have the ability to keep your systems up and running and providing service as often as possible. So it is designed so if a system component fails, then that failure can be replaced or fixed as quickly as possible. So it maximizes the system online time. But high availability does not mean it stops failures, and it also does not mean that there will be no downtime or outages. What high availability does is respond when there is a failure to fix that as soon as possible so that the system can be brought back into service. So what is an example of high availability? Well, let's say that we have an application running on a single server inside AWS, and this server is used by employees to complete their job. If the server goes down, the employees cannot work because the server is down and it's currently experiencing an outage. So if you design this architecture to be highly available, you could quickly spin up a new virtual machine to fail over to, or you could be running two servers for this application, one in active and one in standby mode. So if one server goes down, you can fail over to the second server to serve the employees. But in this situation, the employees may have to log back in, so there could be a bit of downtime, which is okay. It's not what you want, but with high availability, some downtime can be expected depending on your design. So the goal of high availability is to reduce outages and stay operational, fast, and automatic recovery is best. But there is usually downtime, even if it's very brief. Now let's go over fault tolerance. What do you think of when you think of fault tolerance? It is similar to high availability, but fault tolerance is the actual ability of a system to keep operating in the event of a failure. So one or more of the system's components fails, but the system is able to continue on with those faults failing. So a fault-tolerant design must continue to operate. Let's go back to our earlier scenario. In this case, we are designing for fault tolerance, then we would have two active servers serving the one application. If one server goes down, then that second server is already active and will continue to serve the employees, and there is actually no downtime in this situation. So fault-tolerant designs operate to minimize failures, but also to continue to operate through failure. And these system designs are usually more expensive than high availability designs. Okay, let's wrap up this lesson and look at disaster recovery. Disaster recovery is a bit different from fault tolerance and high availability because fault tolerance and high availability are all about designing systems to operate through a disaster. Disaster recovery is all about what we need to plan for and also what we need to do in the event of a disaster. And having a disaster recovery plan is crucial because the worst time to try to recover from a disaster is in the middle of that disaster. Disaster recovery needs pre-planning and also steps to complete the disaster recovery process. So when that disaster occurs, you are already set with a plan to recover your systems as quickly as possible. Maybe you have an on-site backup to switch your environment to, or maybe you use AWS as your backup site and have CloudFormation templates ready to go to provision your environment inside AWS after the disaster. And it is essential to have backups of your environment stored off-site, stored in the cloud, but definitely not stored in the same building as your system. Because if that building is damaged, then so are your backups. So you need a plan to protect your data and store backups elsewhere. And it is best practice to run disaster recovery exercises to practice this process, so in a real disaster, the process goes smoothly. We must protect our systems. Before the exam, make sure you know how to best recover for different scenarios and the best choice for that recovery using different AWS services. In our next lesson, we'll continue learning all about fundamentals and learn about elasticity and scaling. Thanks so much for watching.